Okay, students, now we'll start with chapter number 2. This is the third lecture. Chapter 2 is motion along straight line. Okay, we will start with section 2.1, which is in page 34. Displacement, time, and average velocity. We need to start with this shape. You need to be careful with it. If we have 2 points, point A and point B, starting point and end point, okay? We have the R displacement, which is the straight line between the 2 points, which is the shortest distance. The shortest distance and which has an arrow or a direction, this is a vector, which is a displacement. But if we have this distance, there is no direction for this distance. It is not a straight line. We can go in also another distance. We have many distances, but we have just one displacement from A to B, which is the straight line. And we need to denote by it by a sample, for example, R, with an arrow over it to say this is a vector. Now we will deal with this experiment, this virtual experiment. This is me, and I am on a straight line, which is the X direction, for example. And I can take the scale as I like. So I take these steps as 10 meters, 20, 30, 40 meters. And this is also 10, 20, 30. This is in positive and this is in negative. This is not theta, this is negative. In negative direction. This means that this direction is forward and this direction is backward. Easy? Now, if I do two actions, the first, I was at the origin. I need to have or to define a reference point. The reference point, which is the starting point, I can take it as the 0. So I will take the X initial, or the X1 is 0, and the time at this stage is 0. It is the starting point. The first action, I move forward from 0 to 30 meters. When I measure the distance or the position, or I measure also my place, it is 30 meters. When I look at my watch and I see the time, it is 1 minute. 1 minute means 60 seconds. We can convert it easily. So the time at T, at the second point, is 1 minute or 60 seconds. Then I move backward to 20 meters backward from the initial reference point. It is a minus 20, minus 10, minus 20, minus 30. This is minus 20. And when I measure the place or the position here, it was negative 20. And when I measure the time, it was 3 minutes starting from the initial point. So I was at T equal 0, T equal 1 minute, T equal 3 minutes. Okay. We need now to calculate something known as the change in place, or the rate of change, okay, in place. In the first action, I see that X initial, which is equal to X1, I choose to name the position by x because we are on x axis. We can use the y axis, but we can use here x axis. X initial, which is x1, I choose it to be 0. And x final, which is x2, is 30 in meters. This is the unit. And it is positive 30. The t initial, which is t1, is 0 second. In SI units, we need to use the seconds and meters. We don't need to use the minutes. And t final, which is t2, is 60 seconds, which is 1 minute. Now, it is important to know what is the rate of change in my place. What is my speed or velocity? Speed and velocity are different things. We will talk about them. The rate of change is the average velocity or average speed. To tell you something, when we talk about the vectors or the displacement, it is the velocity. When we talk the change in distance, it is the speed. The velocity is vector, but the speed is not. Okay, the average velocity or the average speed in our direction here is the change in a place over the change in time or on time, which is delta x over delta t. This symbol is delta, which is the triangle, is delta, means the change in x, change in time, which is x final minus x initial over t final minus t initial. What is x final? It is x2, which is 30. What is x initial? It is x1. What is t final? It is t2. What is t initial? It is t1 in our situation here. Okay, now we need to start put our numerical values in our formula. V average is equal to x2, it is 30, x1 is 0, it is the initial place, over 60, which is t2, over t1 or t initial. The units are meters over seconds. Now 30 meters minus 0 meters, it is 30 meters. We can add and subtract the same quantity, meters from meters and second from second. It is 30 over 60 meters over second, which is a half meter over second. Look at this now. We have steps. We start to understand the physical or the concepts in physics. We draw our graph or scheme. We understand all of our problem. We know the initial point, the second point, the final point, and draw it and understand the problem well. We recognize the variables or the parameters, which are x, the position, t, the time, and we also know and find the numerical values for them, which are given. Now we have the next step. We need to know the law, the physical law, which is the formula, which is V average, which is delta x over delta t, the change in place or position over the change on time. The next step, we need to substitute the numerical values in its place in our formula. The final step is to find the result with the units, and we need to know where is the direction of our motion. It is positive here, that means it is in the positive x-axis or to the right, okay, or forward. Now let us look at the second action. I was at 30 meters, then I go to minus 20. My first time is 1 minute, then my final time is 3 minutes. Okay, I understand my second part of my problem. I need to know the variables and the parameters, the numerical values of them. Now in this stage, I have a new x initial and x final. X initial in this stage is x2, which is 30. X final, it is x3, which is minus 20 meters, because I go backward and I pass from my original place and go to the negative direction. This is negative direction, as we told you before. Okay, what about the time? The time at initial point now in this stage is 60 seconds. Then the time at the final point, it is 3 minutes, which is 3 multiplied by 60 seconds for each minute. Each minute is 60, which is 180 seconds. Now, what is my average velocity in x direction? Now, I asked you before about the rate of change in my place, and I didn't ask you about the direction. But after we solve the first part, we know that the change of rate is the average velocity, and the direction is important in our solution now, which is in x direction, positive or negative. So I asked you now, what is the average velocity in x direction? So average velocity, it is the change in place, which is delta x, over the change in time, which is x final minus x initial over t final minus t initial for this stage, okay, which is x3 minus x2, not like the first one, over t3 minus t2. Now I know the numerical values. x3 is minus 20, minus 20, minus 30, which is the initial place, over 180 minus 60. All of this is in meters over seconds. You can put meter, second, but it is, if you know that the units of the velocity is meters over seconds, you can put it aside. So negative 20 minus 30, it is negative 50. 180 minus 60 is 120. This will be equal to minus 0.417, I rounded it, meters per second. The units of the derived quantity, which is the velocity, is meters over seconds. What about the minus sign and the positive sign in the first part? The negative and the positive signs mean that the direction of the motion is to right or to the right or to the left, or positive x minus negative x direction, or forward or backward, or positive y or negative y if we are moving vertically, and so on. I hope you understand this. It is easy to be understood. We will solve more examples and you will need to solve more examples. Thank you. Hi students. Now we'll talk about instantaneous velocity. It is different than the average velocity. Remember me in the previous example? I was initially at point x equal to 0 at time t0, which is the original. And in the first action, I go to point x equal 30. And the time was 60 seconds. And my average velocity, if you remember, it was delta x over delta t, which is a half meters per second. Delta x over delta t, remember this notation. Delta means the change in change in position between two vast positions, okay? But what if we take the time or the change in position to small values? Because any body is moved small tiny small displacements at a time, not change from 0 to 30 instantaneously. It is gradually, okay? But if I reduce the period of time to be very small, very small, it will not be delta t, it will be dt for small, tiny, small periods of time. In this case, I will not have in my question or my problem delta x, which is a vast change in position. It will be dx. dt is the same delta t, but when delta reaches 0 or reaches small number, a small value. And the same for the dx. It is the same as delta, but it is the limit for delta when delta goes to 0. So for infinitely small periods, delta t will go to dt, and delta x goes to dx, or in different mathematical notations, the limit of delta x over delta t when delta t goes to 0 is dx by dt. This is the instantaneous velocity, okay? It is the derivation. It is the derivative. Did you remember before the example? We just have this simple sheet. If we have f of x, if you remember that, x squared plus 2x plus 1. What is df by dx? It is equal to 2x plus 2 plus 0. If you remember that, it is the same delta f over delta x. We need to take the limit when delta x goes to 0. This will give us df by dx, which is the first derivative. Now we see that the first derivative of x with respect to t is the instantaneous velocity. For example, if we take this x as a function of t, x of t is equal to 3t cubed minus 4t squared plus 5 in meters, okay? If I ask you to find the position at time equal 3 and name it x2, I need just to put t equal to 3 in this function. It will be 3 multiplied by 3 cubed minus 4 3 squared plus 5. It will be 50 meters. What about x? If I name it x1 or x initially at t equal to 0, I just need to put 0 in place of t. It will be 0 minus 0 plus 5. Okay, what if I need to calculate the average between the time 0 and 3? It is easy. I need to find delta x over delta t. I have x1, x2. Delta x is x2 or x final minus x initial, which is 50 minus 5. I named this one 2 and this one 1. 50 minus 5, which is 45, over the change in time, which is 3 minus 0, which is 3. This will be equal to 15 meters per second. I can find the average velocity if I have the function of the position in time. What about the instantaneous velocity? That's easy. I need to take not delta x over delta t. I need to take the first derivative of x with respect to t, which is dx over dt. This is a calculus course, so I can derive this with respect to t. Assume it in x, assume it f of x is equal to 3x cubed minus 4x squared plus 5. What is df by dx? It is easy. 3 by 3, which is 9x squared, minus 2 by 4, which is 8x, plus 0. I don't have f, I have x, and don't have x here, it is t. So I have dx by dt, the change in position in time, which is equal to 9, I don't have x, it is t squared, minus 8t. This is it. I have the instantaneous velocity as a function of time, a function of time, yes. This is t. You will find it right. Just a typo here. It is t squared, 9t squared minus 8t plus 0. Okay, now if I need to find the instantaneous velocity, okay, I have the velocity as a function of t. Just I need to put the time that I need the instantaneous velocity at that time as a function of this v. So the instantaneous velocity at t equal 3, just I put the 3 here. It is 9, 3 squared, negative 8 multiplied by 3, which is 75 meters per second. What is the instantaneous velocity at t equal to 0? I need to put 0, 0, it will be 0. What is the instantaneous velocity at t equal to 1? Put 1, 1 squared is 1, 1 is 1. This will be 9 minus 8, it will be 1, the instantaneous velocity. And so on. You can try that by yourself. And we will do it in the class. See you. Bye. Hi students, now I'll talk about the acceleration, which is section 2.3, which is in page 40. Okay, now let us imagine this experiment. We have a car toy, and this toy is sliding over this incline. Okay, at t equals 0, the car was here. After 1 second, it was here. It moves this distance. After 1 second, at t equal 2, it will be here. This distance is more than this one because its velocity increases. We know that if we throw a body as a free fall, we will see that it will accelerate. We are talking about the acceleration, which is the change in velocity with respect to time. We have the motion in this direction in this experiment. The direction of motion is with a slope of theta of that incline. We can make it horizontal to study this problem. So I make it horizontal and I name it x direction. It's okay. I can take this xy plane and I can rotate it as I like. The motion of the car is perpendicular in the direction of x direction. Now this is my system. I understand it now. This is the first step. The initial point, the original point, is at x equal to 0, at time equal 0. This is the first point. After one period of time, which is 1 second, the car was at x equal to half meter. The unit of distance here is meter. After 2 seconds, the car moves more distance than before. It is at x equal 1.3. The distance is more. After, for example, if we need to go more, after at t equal 3, at the 4th position, the x position is 3 meters. We know that we have change in time, we have change in position. In this case, we have velocity. So we have velocity in the first period, which is v1. I name it v1. I can name it v average 1. We have in the second period second velocity, second average velocity. We have in the third period third average velocity. We have all the variables or the parameters which are the positions x and the t's to calculate the velocities. It's easy. We can find v1 as we learned before. It is delta x over delta t in the first period. Delta x, x2 minus x1, which is half minus 0, over t2 minus t1, which is 1 minus 0, which is half meter per second. Here the units is meter and the units in the denominator is second. This is the first average velocity. The second average velocity, it is x3 minus x2 over t3 minus t2. It will be 1.3 minus half over 2 minus 1. It will be 0.8 meter per second. The velocity now is more than the velocity before. That means the velocity changes its magnitude. This means we have acceleration. Let us see the third one. The third velocity is x4 minus x3 over t4 minus t3, which is 3 minus 1.3 over 1 second. It will be 1.7 meter per second. Also, the velocity, the average velocity here is more and more. Okay, when we have change in velocity, then we have acceleration. This is the mean of acceleration. Sometimes that change will be in positive direction, sometimes in negative direction, and we have positive acceleration and negative acceleration. We will see that in the examples. Now this is our problem. This is it. We have the positions again and again, and the velocities. We have a change as we compute a change in position with respect to time, and we find the average velocities. We can also calculate the acceleration, which is the rate of change. The acceleration is the rate of change of velocities with respect to time. It is easy. It is the same steps. The acceleration is delta v over delta t. The velocity is delta x over delta t, but now we have delta v over delta t. We have another step, which is v final minus v initial over t final minus t initial. Okay? The instantaneous acceleration, again and again, it is the same as average acceleration, but when delta d goes to 0, so it will be not delta v over delta t, it will be dv over dt. It is the derivative of the velocity with respect to time. It will be easy, you will see that. Okay, let us compute now the first acceleration in the first periods and the next acceleration, a1 and a2. a1 is delta v, which is v2 minus v1 over t2 minus t1. So v2 minus v1, v2 we computed it as this is v2 0.8 minus v1 0.5 over the time period. The first period from 0 to 1, the second period from 1 to 2. We will take the average between them, so we will take this at a half second, or we will take 1 second, 2 seconds, and the change of them is, the change of this period is 1 second. Okay, if we take the end of that period, 2 minus 1, so it will be 0.8 minus half, it will be 0.3 over 1. The denominator is meters per second, it is velocity. The denominator is in seconds, which is time. So we have meter over second over second. Of course, the value is 0.3 meter per squared second, because we have here a second and here another second. What about the other acceleration value between? What is the rate of change of velocity in the second stage? It is v3 minus v2 over t3 minus t2. We can put the units at each value, or we can put them at the end of the expression. Okay, the velocity v3, we computed it, is 1.7. v2 is 0.8. The change of time is 1 second. Then the acceleration will be 0.9 meter per squared second. This is the average acceleration between different periods. What about the instantaneous acceleration? It is the same as instantaneous velocity. It will be easy. We know from before that we may have x as a function of t. Then we can find v of t. Then we can find a of t, because a is the derivative of the v with respect to t. If we have a function of t, which is x is equal to 3 t to the 4 minus 2 t cubed plus t plus 5, it's an arbitrary function. Then the velocity as a function of t is the derivative of the position with respect to t, which is 12. If we derive this function, it will be 12 t cubed minus 6t squared plus 1, and the derivation of t5 is 0. And the acceleration is the derivative of the velocity, but the velocity is the derivative of x. So the acceleration is the second derivative of x with respect to t, which is d2x by d squared. Okay, you need to derive the x of t, the position function, 2 times to reach the acceleration as a function of t. In this case, we can find any instantaneous position or velocity or acceleration as a function of time at any time. You can solve x of t is equal to 7 at t equals 7. We can find it. We can find x at t equal to v at equal to t equal to. We find the acceleration at t equal 1. It is easy. Just put 1 at in place of t. 36 multiplied by 1 squared minus 12 multiplied by 1, it will be 24 meter per squared second. Look at here. A at x is equal to 5. It's okay. When x equal to 5, when t equal to 0, this is 0, and this is 0, and this is 0. So when we put the acceleration at t equal to 0, it will be 0. It is easy to find the magnitude or the value of a function if you have the independent value of that function. You will see more example about this subject. Thank you. Hi students. Now I will talk about distance and displacement. As we see here, if we have 2 points A and B, we have 2 paths between them. The first one is the distance. It is not a vector, it is a scalar. The smallest distance between 2 points is the straight line. The straight line, if we have it as a vector, that means I have a starting point and an ending point. In this case, I have this vector which is a displacement. This vector, I can name this vector, maybe I can name it A, but because A starts from A to B, I can take it positive, for example. But if I need to take it in the opposite direction, yes, it will be minus A. Okay, and another example, if I have a point A, point B, and point C at this tree. If I have that displacement from A to B is 4 meters, and from B to C is 3 meters. This is displacement and this is displacement because we are seeing vectors. And also we have from A to C 5 meters. That means I have a right angle here, because when I use the Pythagorean theorem, if I have don't look at the scales of the drawing. If I have 3 meters, 4 meters, and this is C, for example, this is A, and this is B, I know that A squared plus B squared is equal to C squared. So A squared is 3 squared plus 4 squared is equal to C squared. This is 9 and this is 16 equal to C squared. So I have it 25 equal to C squared, and from it C is equal to plus 5 or minus 5. It is a distance or a displacement. It is a positive value. So I will not take the negative value. And the unit is in meters. Now look, the path from A to B to C is a distance. If I take it not as a straight line from here to here, but the distance from A to C directly is a displacement. It is a vector. So a displacement is the shortest distance between 2 points, and it is a vector. Let us look at this example. If we take the distances between, we have many distances, but we have just one displacement between Las Cruces and Washington, D.C. If we look at these tracks, we have this track. It is about 2008 miles. And the time for this track is 30 hours. This is the time. And this is the distance. I can compute the speed in this case. The speed is scalar, which is equal to distance divided by the time, which is equal to directly 2008 divided by 30. The units of the distance is miles, and the units of the time is hours. So I can calculate it. Yes. 2008 divided by 30. So the speed on this path is equal to 66.93 miles per hour. Okay, if I look at the displacement from Las Cruces to Washington DC, it is 2,800 kilometers, not in miles. I will convert this to kilometers. You need also to compute these two tracks, and you can also calculate the speed through them. Okay, the distance in kilometers to 2008. This is the distance. In miles, I need to write it in kilometers. How can we do that? I know that 1 is equal to 1.60 almost kilometers for every mile, which is also equal to 1 mile over 1.6 kilometer. Okay, I need to write this in kilometers, so I need to cancel the unit from the distance and from the conversion factor. I will use this value. So distance will equal to 2008 miles multiplied by 1. This is 1 and this is 1. I need to use this one. 1.6 kilometers divided by 1 mile. So easily I can cancel this with this, and I have the final value multiplied by 1.6, which is equal to it is roughly 3,000 and 280 kilometers. So it is 3,212.8 kilometers. So if I need to calculate the speed, it will equal to the distance, which is 3212.8 divided by 30 hours, will equal to 107.093 kilometers per hour. This is the speed in kilometers. This is the speed in miles. It is the same speed with different units. Now, how much the displacement between the first point and the final point? I can compute it like this. The displacement is equal to 2,800 kilometers. What if I take the same time and I need to calculate? In this case, I will not calculate the speed. I will calculate the velocity, which is a vector quantity, which is equal to the displacement divided by the time, which is equal to 2800 kilometers divided by 30 hours. It will equal to this is the velocity. It is just v. If I need to calculate the velocity through this straight line, which is a vector, which is a displacement, not a distance. I have many distances, but I have just one displacement. Please calculate the distances in kilometers, and you can calculate also the speed and recalculate the velocity in this through this track, straight track. Thank you. Okay, students, now I will solve another example for distance and displacement. If we have this shape, the track from A to D passing through B and C, if I go through this track, this will be a distance or a displacement. It will be distance. How much that distance in this case? It will be 5 plus 6 plus 5, which is 16 meters. How much the displacement? It is from A to D this directly, which is the same as this displacement, which is 6 meters. Now, if I need to calculate the speed will be calculated by using the distance, not the displacement, because the speed is not a vector quantity, which is this track, which is equal now to 16 meters over the time, which is 8 seconds. In this case, it will be 2 meters per second over 1. It's okay. If I need to calculate the velocity, which is the displacement, in this case, it is 6 meters over the same time, seconds, which is equal to 0.75 meters per second. Now, this is simple because I know the distance and the displacement directly. But what if I have a different problem? Now I need to understand the figure. I need to find the average speed and the average velocity. What is the difference between the average speed and speed in the first example here? It is the same. This one also is speed average, and this is velocity average value. We will see now how to apply and calculate the average speed and the average velocity. If we need to calculate the average speed, it will be a distance divided by a period of time. Also, if I need to compute average velocity, it will be equal to displacement over time. How can I know the distance and the displacement? I need to know the position of a moving body or person or car or something. Now I have many points, A, B, and C, and I have a girl and a boy, a walking girl and a running boy. I need to calculate the speed and the velocity, the average speed and average velocity for both of them. Who has the speed and who has the velocity? Remember that the average speed is not vector, but the velocity is a vector. Where is the vector in this movement between the girl and the boy? The movement of the girl is a vector quantity, and this value from A to B, this arrow is a displacement. But this track is a distance. So I need to calculate speed here, which is average speed, and also I need to calculate average velocity here from A to B and also from B to C. Let us do it now. Now, the average velocity from A to B, which is equal to the displacement between them, which is XA and XB, the displacement between them equal to XB minus XA divided by that period of time, which is time at point B minus the time at point A. I'm starting solving. In this case, T and X at B, they are final values. This is T final and this is X final. Also, T at A is T initial and X at A is X initial. Now, if I start calculating, I need to put the time in minutes. So I need to use it in this case. XB equal to 300 meters minus 0 over the time is 4 minus 0, which is equal to 300 over 4. This value is equal to 75 meters per minute. This is the average velocity. I can also name it V average. If I take it as a vector, it is to the minus x-axis. Okay, now I need to use the seconds, not the minutes, in my units. So this value is equal to, or from the beginning I can change the time in seconds. I will do that. TA is equal to 0 minutes, which is equal to 0 seconds. TB is equal to 4 minutes, which is equal to 4. Each minute is 60 seconds. Just I substitute 60 seconds in minutes. So TB is equal to 240 seconds. TC is equal to 10 minutes, which is equal to 10 minutes. The minute, each minute is 60 seconds. So is equal T at C is equal to 600 seconds. Now the boy and the girl pass the tracks at the given times. The boy and the girl are met here at this point, because the boy is faster than her. They met here and then they continue each one in his track. Okay, I will calculate now the average velocity again, but in seconds. V average from A to B is equal to delta x over delta t, which is equal to x final minus x initial over t final minus t initial, which is also equal to xb minus xa over tb minus ta. All this is in meters and this in seconds. In this case, V average from A to B is equal to 300 minus 0 divided by 240 minus 0, which is equal to 1.25 meters per second. It is a vector quantity, so I need to put the direction in minus x direction. Or to the left, or to the west. Okay, now I will compute also the average velocity from B to C. The average velocity means that I could calculate the velocity for the girl, not for the boy. Okay, because it is a vector quantity in this case, which is equal to delta x over delta t again, and equal to x c minus x b, which is x final minus x initial over t final, which is x t c minus t b. In my case here, x c is 800 meters minus x b is 300 meters divided by t at c 10 minutes, which is equal to 600 seconds minus 240 seconds. This is in meters, meters, seconds, seconds. Also, I can put them in this way: 800 minus 300, 600 minus 240. I can put them meters per second on a side. The final value will be equal to, it will be easy, 500 over 360 meters per second, which is equal to 1.389 meters per second. We need to see here the velocity from B to C is 1.38, but the velocity from A to B is 1.25. Here, for the second part, the gear was faster than the first one. So what if I need to calculate the average velocity through all the track from A to C? It will be in this way. Look at this. V average from A to C, which is equal to delta x from A to C over delta t from A to C, which is equal to x final, which is x at C, minus x initial, which is x at A, divided by t final, which is tc, minus ta. I can put the values now, which is equal to x at C 800 minus 0 divided by t at C 10 minutes, which is 600 seconds, minus 0 second at the point A. Now this is equal to 800 over 600, which is equal to 1.3 okay, meters per second. This is the average value. We have three average values. Average value V average from A to B is equal to, as we compute it now, it is 1.25 meters per second. V average from B to C is equal to 1.389 meters per second, and the V average, the final value from A to C, that is depend on the first point and the final point, which is 1.3 meters per second. Now we calculate the average value of the velocity for the gear, because it is velocity, because it is a vector from A to B to C. Now I need to calculate the speed. The speed is for the boy. The speed I will use in the speed, I will use the distance. I will not use the displacement. Okay. But wait now, I have a different track for this boy. I have half a circle. Okay, what is the length of this track? I know that for a circle which has a radius r, that all of this the distance is equal to 2 pi r, is equal to the total distance s. Okay, but I have a half circle, not a full one, so I need to divide it by 2. For the track from A to B, this is A and this is B. This track, this is its radius r, and this is s, is equal to the distance, which is equal 2 by r, but divided by 2. So the 2 will cancel with the 2, which is equal to by r. Okay, how much r? The radius in this case. The radius is a length. We know that the girl walked from A to B, and the displacement was 300 meters from A to B. From A to B, 300 meters. So half of this distance is 150. This is equal to r. So S is equal to pi multiplied by r, which is 150. Okay, I can use it and can compute it. 150 by is equal to 471 point approximately 24 meters. This is the distance from A to B. Now I have also another distance from B to C. I need to know the radius here, radius B to C. This is the radius from A to B. I know that the displacement from B to C is 800 minus 300, not 800. The 800 is from A to C. So the displacement from B to C is 500 meters. Half of it is equal to 250 meters. So S from B to C is equal to by, not 2 by because we divided by 2, by multiplied by the radius, which is 250. In this case, S is equal to 700 5.4 meters. Now I have two distances, the distance from A to B and the distance from B to C. Now I can compute the speed. The speed is not a vector because I have no constant direction for this path and this path for the running boy. Okay, I need to calculate the average speed from A to B, which is equal to the distance divided by the time. In this case, the distance is S from A to B divided by the time. The time, it is the same time, which is 4 minutes. We computed, which is 240 seconds. So this will be equal to 471.24 meters divided by 240 seconds, meters per seconds, which is equal to 'So the average speed is equal to 1.9635 meters per second. Also, I can write it as speed average. It's okay. Now I need also to compute the average speed from B to C, which is equal to the distance from B to C is SBC over the time. The time from B to C is 10 minutes minus 4 minutes, which is 6 minutes. In this case, if you remember that we take 600 minus 240 seconds. So the time here is 600 minus 240 in minutes, in seconds. This will be equal to SBC is 785.4 divided by 360 meters per second, which is equal to 2.18 approximately meters per second. This is the average speed from B to C. We can note that the average speed for the boy is more than the average velocity for the girl, because the distance of the running boy is more than the displacement for the girl, and they met at each point, so he should be faster than her. Yes, that's right. He is faster than her, because look at here. Her velocity from A to B is 1.25, but his speed is faster here, 1.96. Also, her velocity from B to C is 1.38, and his speed is more than 2. He's faster. Now I'll compute his total speed from A to C. In this case, I will do this. I'll use the new paper. He passed through these two tracks, A, B, C, and this distance is 471.24 meters, and this distance is 785.4 meters. So the distance, total distance, is equal to, we need to add them together, 1,256.64 meters. This is the total distance. How much the total time? The total time is, as we see, 4 minutes, 10 minutes. From here, from A to C, he spent 10 minutes, as the girl spent. Okay, 10 minutes. So the total time is equal to 10 minutes, which is equal to 600 seconds. Now I can compute the average speed, not velocity, from A to C. In this case, I will use the total distance, which is 1256.64 divided by 600 meters per second. Okay, divided by 600. The last total speed, 2.0944 meters per second. We can approximate this, remove these two digits. So now, if we look at the speed and the velocity, the speed average from A to B, it was, how much the value? It is 1.96, and we can approximate this, meters per second. The speed average value from B to C is equal to 2.18 meters per second, and the average speed from A to C, and the total path is equal to 2.09 meters per second. We can see now that the speed of the running boy is more than the velocity for the walking gear in each track from A to B, from B to C, and from A directly to C. You can compute these values. Now, the last page in this sheet is this one. We need to use graph. I will use this simply graph now, and I will use another one later in another sheet. Okay, we need to understand how to use the plane of x, y, the xy plane. You need to do the, in mathematics we know that x and y plane, and we can draw any function between through them. But in physics we don't have always x and y. We have time, position, distance, velocity, or something else. Okay, on x-axis we have the time, so this is 0 time at the origin. We have 1 second, 2 seconds, 3 seconds, and so on. And the displacement on the y-axis. So this is the position. This is 1 meter, 2 meter, 3 meters, because we have the unit here and we have the unit here. Okay. What if I ask you, where is the position of the body? This is a moving body. Where's the position at t equal to 0? It is at the origin. If we have, this is the line, this is 1 meter, 2 meters, 3 meters, 4 meters, and so on. We are here at t equals 0. Okay, at t equal 1, where we are at a distance or displacement 1. This is at t equal 1. Okay, at t equal 5, this is at t equal 5, we have moved to x equal, in this case we have here t, and here the position, maybe we can name it x or y or anything else. So at t equal 5, we have position 5. This is 5. This is at t equal 5. At t equal 6, we are at the same position. At t equal 7.5, we are at the same position. At t equal 8, 9, 10, we are at the same position. So we spend the time from 5 to 10, and we are at the same position. That means we are standing and stopping. We don't have any movement here. We are here for 1, 2, 3, 4, 5 seconds. But the first track from time 0 to time 5 seconds, we are moving. We are change our place and position. Okay? Okay, now at t equal 10 seconds, we know that we at x equal 5. Okay, at t equal 11, we are at x equal 3. We come backward to x equal 3. So we go and then come back. At t equal 12, we are at x equal 1. At t equal 12, after 12 seconds. At t equal 12.5, approximately, we go back to our first position. I can understand many things from this graph. Okay, if I need to calculate the speed during the time from 0 to 4, from 0 to 4, 0 to 4, if I need to calculate the speed, I don't know where is my movement? Is it in X direction, Y direction? So it is speed. I don't know where is my direction, so I can't call it velocity. Okay, the speed is equal to delta X, or the change in position, over delta T, which is equal to X final minus X initial over T final minus T initial. In our case, it is X at T equal 4, so I will put it X4 minus X0 from 0 to 4 over T4 minus T0. This is equal to X at T equal 4 is 4 meters minus X at T equal 0, it is 0. T4, which is 4 seconds, minus 0, which is equal 4 minus 0, 4. 4 minus 0 is 4, which is 4 over 4. And the value is, the speed is, or the average speed is 1 meters per second. Okay, calculate the speed during the time from 6 to 8. 6 to 8. This is 6 and this is 8. That's easy. Speed from 6 to 8 is equal to X at 8 minus X at 6 over T at 8 minus T at 6, which is equal to X at 8, this is X at 8, is equal to 5, minus X at 6, it's the same value, 5, because we were stopping here. Okay, the time T at 8, 8 minus 6, which is equal to 0 meters per second. If we have velocity and speed, or speed 0, that means we are stopping. We are, and you can remember, if you can remember, and you can, the slope, which is equal to delta y over delta x, which is equal to y2 minus y1 over x2 minus x1. In this case, y final minus y initial over x final minus x initial. But in our case, this is position. Position means x. I suppose it x. I can suppose it y. It's okay. x2 minus x1. But the x axis here is time. So I will take it t2 minus t1. Okay, the slope, if it is in mathematics, delta y over delta x, and in physics I see that the slope is delta x over delta t. Delta x over delta t is the definition of the speed and velocity if I know the direction. The speed in this case, I can call it average speed. You can compute also the average speed in this period from t equal 10 to t equal 12 or 12 and a half, and you will find that x final is less than x initial, and the value will not be positive. It will be not. It will be negative value. The negative value means that the body or the movement, car or the person, is moving in the opposite direction, not in the positive direction, because we suppose that the right direction is positive, and we compute here positive values, and there's no positive and negative for the zero, and the negative value means that the body moves to the left or to the opposite direction. Is that clear? Thank you. Okay, now I will talk about graphical interpretation of average velocity. You can find this in the text in page 24 and 25. Yes, we will use a graphic representation for position with respect to time. We have the time in seconds, not in meters. Okay. In the XY plane mathematics, this is XY plane. As I talked before, in physics, we can use the x-axis to represent the time, and we can use the y-axis to represent the position. Okay, the positions here in meters, but the time in t. The dimension of time is t in seconds. Okay, you need to understand and to know that the body is not moving through this track, along this track. It will not come in this way. If we put in this way, in this direction, we can see that this is x direction, positive x direction, and this is the negative x direction, and this is the time axis. We can name the positive x direction as right direction. Also, we can name it east. We will see that in many examples or questions. Also, the negative x-axis, maybe we name it left sometimes, or west. And the positive y direction, we can name it positive y, or north, or upward, if we are working with just two dimensions, and the same for the negative y direction. But now we are working with time. We don't have positive and negative time in this example. Okay, at t equals 0, this is the time. At t, this is time equal 1, time 2, 3 seconds, 4 seconds, so on. At t equals 0, the position of the body is 0. At t equal 1, the position of the body is here, so the body is moving right. At t equal 2, the position of the body is here, the body moving also right. At t equal 2 point, you can estimate that point. It is a returning point for our body. It will come and reverse its motion. At t equal 3.2 or something like that, the body reaches the origin again. Then it starts moving in negative direction, negative x direction. At t equal 4 seconds, the body is at minus 18 meters, and so on. Also, the body returning point in x, in left direction or west or negative x direction, it is at t equal 5 and something more than 5. The returning point is about minus 36 meters, and so on. Now you can see that through or within from 2 seconds, from 3 to 5, the body passes almost 36 meters in negative direction, or in left or in west. In 2 seconds, from 3 to 4, from 4 to 5, it passes these it changes its position from 0 to negative 36. But from 0 to 2, almost, it changes also its position from 0 to 6 meters. So it spends 2 seconds to move to the right 6 meters, but it spends 2 seconds to move to the left 36 meters. we have changes in velocities during its motion. How can we compute these velocities during these times? It's easy. We know that velocity or speed is equal to x final minus x initial divided by t final minus t initial. We can use any x we need and any time we need to calculate the velocity, and that's what we will do now in our examples. Okay, for this sheet we can start. This graph represents object's motion in the x direction. Assume that the positive direction is in the positive x-axis. Okay, find the average velocity during the times or between from t equals 0. This is t equals 0. This is t in seconds. This is t equals 0. I will use a different color, yes. And t equal 5 seconds. This is t equal 5 seconds. Yes. At t equals 0, I have t equals 0 and x تساوي 0. At t equal 5, the body is here. T equal 5 and x equal to minus 36. I can use this as t initial, x initial, t final, x final. What is the velocity? I can compute now the velocity, because not the speed, because I know the directions. I know that the positive direction in the x positive and the negative direction in the x negative. Okay, so the velocity is equal to x final minus x initial divided by t final minus t initial. From where I reach this formula, I know that the rate of change of that position is the velocity, okay, which is equal to x final minus 36 minus 0 divided by 5 minus 0, which is equal to minus 36 over 5, which is equal to 7.2 meters per second, but with minus sign. The minus sign means that the body is moving in the negative x direction. Is that clear? Okay, I calculate the first velocity. I need you to remember this point. If I have a function y is equal to f of x, I can find the slope is equal to y2 minus y1 over x2 minus x1. In my case here, I really find the slope. Look, I can draw a line between the 2 points. I will make it easy to be seen. This line is going down. That means its slope is negative, and that is what I find. Also, how can I know that? If I move to the right in time, or if I move forward in time, then that position going down. That is the meaning of the negative slope. Now, I will find the next one. The next one, I have t initial 1.25. 1.25. This is 1. This is 1.5. This is 2. 2.5. This is 1.25. X at this point almost is equal to 2 because this is 2, 4, 6, 8, 10. It is easy to be understood. This is my initial point. I have at it t initial is equal to 1.25 seconds and x initial is equal to 2 meters. Okay, what is the second point or the final point? It is at t equal 3. At t equal 3, this is t equal 3. I have this point, the final point, t final is equal to 3 seconds and x final is equal to the same value, 2 meters. Now I need to calculate the average velocity. Velocity is equal to x final minus x initial over t final minus t initial, which is equal to 2 minus 2 over 3 minus 1.25. 2 minus 2 is 0, so the final average velocity between one initial value and final value is 0 meters per second. It is velocity and it is a vector because I'm talking about velocity. What is the meaning of that? Is the meaning of that the body is stationary? No, between these 2 points, the body was moved from this point to this point, but the position or the change in the position is 0 because the body is going away to the positive direction and then return to the same point. Okay, in this case the velocity is 0. You can find the velocity for these 2 points. One of them between 3 and 4. You will see that the velocity is negative. The next one is between 4 and a half seconds and 6 seconds. This is 4.5. This is the point. You can approximate it. And 6, which is this is the point. You can approximate it. You will find that the slope in this way will be positive slope and the velocity will be in positive direction. Now I need to talk about another thing, which is instantaneous velocity. It is easy to be understood. The instantaneous velocity is the velocity at a certain point, at a certain time. Okay, what does that mean? If I look at the time t equal 2.25, this is the time, 2.25 seconds. I need the velocity at this point. How can I find that velocity? I don't have V initial and V final. I have just a point. In this case, I can't draw a line to find its slope, but I can find and draw a tangential line. Look, you have and you can draw this tangential line in this case like this. It is horizontal one at this point. The slope of the for the horizontal line is 0. I can find that. How? The velocity is equal to x final minus x initial over t final minus t initial. Okay, I can pick any 2 points. I will take the first point, the second point at t equal 3, at t equal 4. This is 1 and this is 2. I have the position at t equal 3, x initial, and here is x final. So this will be equal to x final, which is 6, minus x initial, which is the same point 6, because my tangential line is horizontal. Okay, the change in time t final is 4 minus 3, which is the initial time. This case I have 0 meters per seconds. For this is the slope of the horizontal line. Okay, I will take the next one at t equal 3. This is t equal 3, and this is the point. I will not suppose that I need to use this position. I need to again here to draw a tangential line at t equal 3. The tangential line, I suppose it to be tangential. Maybe I will have some errors in drawing this line, but that error will not be that different between person to and another person. Maybe you will draw it like this or like this, but the change will be not too much. Okay, this is the tangential line at t equal 3 approximately. Now I need to choose 2 points. I will choose this point because it is easy to know how much the time and how much the position. If I choose this one, it is difficult to find the time here. If I choose this one, it is easy to find the time. It is 4.5, but it is difficult to find the position. So I search to find any 2 points, easy to pick the time and the position. Easy to pick to find x coordinate and y coordinate. I find this one. I will take it as t final and x final, and I will find look. I can choose this one. I can take it here, t initial, x initial. Okay, t initial, it is 2.25. X initial is 10 meters. This in seconds. Okay, here t final is 5 seconds. X final is 20 meters. Okay, I can now calculate the velocity. Velocity is equal to x final minus x initial over t final minus t initial, which is equal to x final 20 minus 10 in meters divided 5 seconds minus 2.25 seconds. I can put meter here and here, but that will be sometimes difficult and knowing. Okay, this will be equal to 10 over 2.75, which is equal to meters in seconds. Where is this? 10 over 2.75 is equal to 3.63 meters per second. But look, I have an error, a mistake now. How much the position here? It is not 20, it is negative 20. Negative 20. I'm sorry for that, but that is good to make mistakes to learn better. So this is negative 20 and this is negative 20 In this case, it will be 30, not 10, 30. So the final result will be not 3.63. The final velocity, the average velocity will be 10.9 meters per second with negative sign. The negative sign means in negative x direction, or in to the left, or to west. I don't prepare for this mistake. It happened with me. It will happen with you, but be careful that we have positive direction and negative direction. Be careful to take another look to your solution. Also, how I find this mistake, I look to my line. I saw that this line has a negative slope, so my solution at first time is wrong because I have it positive. Then I can correct my mistake. Is that clear? Now the third point at t equals 6. This is t equals 6. This is the point. You can draw that tangential line like this, which has positive slope and positive velocity, and you can pick any 2 points and find the velocity in this case. Thank you. Hi students, now I will talk about velocity versus time graph, and we need to understand what is the acceleration. Okay, starting using this graph, I need to ask, I talked before that in mathematics we have the x coordinate and the y coordinate, and we have a point which is xy. But in physics we have, until now we know that t at the x axis and the position or x at the y axis. In this example we have the velocity at the y axis and the time at the x axis. So the x axis carry the time in seconds, and the y axis carry the velocity, not the position as the previous example, which is in meters per second. Now simply I need to assign these points in this graph. I need to put each point at its position. Okay, at t equals 0 I have the velocity is 0. At t equal 1 the velocity is 1.5. This is 1, 2, this is 1.5. At t equal 2 the velocity is 3. At t equal 3, 4.5. Okay, this is 4.5. At t equal 4 I have the velocity is 6 meters per second, and at 5 it is 7.5. Okay, this is the point representation in this graph. Now if it is required I can draw a line. This straight line if we get back to mathematics, I have the equation of the straight line is y is equal to ax plus b. I should know that A is the slope and B is the y-interception, and x is x, y is y. How can I calculate A? A, which is the slope, is y2 minus y1 over x2 minus x1. This is the slope. The slope in the previous example was the velocity. We can see that the slope was the velocity, which is delta x over delta t in the previous example. But now we don't have the position at y-axis, we have the velocity. So what if I need to compute the slope? If I need to find the slope in this graph, so slope is equal to delta v over delta t, which is v2 minus v1 over t2 minus t1, which is the same as v final minus v initial over t final minus final t initial. The change, the rate of change in velocity during a period of time is the acceleration. So I can calculate the slope for this line. The slope will be, I can pick any 2 points to calculate the slope. I can take this and this, which are the same from the table. So I can take this, which is t final and v final, and this is t initial and v initial. Okay, t final is 4 seconds and v final is 6 meters per second. T initial is 2 seconds and v final is 3 meters per second. Now I can find the slope. V final 6 minus 3 divided by 4 minus 2, which is equal to 3 over 2, which is 1.5. What is the unit? Get back to the unit. The units for the velocity is meters per seconds. The units for the time is seconds. So I have it meters per seconds per seconds. In this case, it will be meters per second multiplied by 1 over second. It will be meters per squared second. So the unit of the acceleration is meter per second squared, but the unit for velocity is meter per second. Is that clear? Okay, I'll move to the next example. Okay, what I represent in x and y. In x it is the time and y it is the velocity, v in meters per second, and at x-axis it is the time in seconds. Okay, now I have this graph for a moving body. I have positive slope, zero slope, negative slope. For velocity, the slope is the acceleration, and here also the slope is the acceleration, and also here the slope is the acceleration. The slope is positive, so I had positive acceleration here from 0 to 5 seconds, and we have 0 slope from 5 to 10. We can compute them. Also we have negative slope from 10 to 12 and a half. So we have positive acceleration, zero acceleration, negative acceleration, we can call it deceleration. Okay, we need to fill the table. How can we read the information from a graph? At t equals 0, what is the velocity? At t equals 0, the velocity is 0. I don't need to put meters per second because they are put in the title row. Okay, at velocity equal to 1 meter per second. How, at what time the velocity is 1? This is 1 and this is the time. I come from the y-axis, which is the velocity, and get back to the x-axis, which is the time. The time was 1 second. How much the velocity at t equals 6? This is t equals 6. How much the velocity? How fast the body is? It is 5 meters per second. At t equal, what is the time when the body has the velocity 3 meters per second? This is the time. Okay, it is 3 seconds. But wait, we have at B and at D different thing. At velocity 1 meter per second, I find that the time is just 1 second, but I have another point that the velocity was 1 meters per second, which was at 12. So I have 2 times. Also at 3 meters per second, I have another time the body have that speed at t equal 12, 11. So the body has the same velocity twice. Okay. The first when the body is accelerate. The second when the body is decelerate. Now at t equal 12 and a half, the speed or the velocity of that body is 0. It is stationary. When the velocity is 0, then the body is stationary. When the velocity doesn't change, like from 5 seconds to 10 seconds, that means the acceleration is 0. So the body at this in this period has uniform motion or velocity. Because the acceleration is 0. Okay. What if we need to compute the acceleration from 0 to 5? The acceleration from 0 to 5 is the same from 0 to 1 or from 0 to 2 or from 0 to 3 because we have a constant acceleration, a constant slope. We have a straight line, so we have a constant slope. Also, if we need to take an the instantaneous acceleration at a point, the slope is the same for all the line and for each point. So the instantaneous acceleration and the average velocity acceleration is the same. So the average acceleration is equal to v2 minus v1 over t2 minus t1. I can pick any 2 points lying on the line. So v2, I can take this and this, or this and this. I'll take this. v2 is 5 minus 0 divided by 5 t2 at this point. t1 is 0, which is 5 over 5, which is equal to 1 meters per squared second, which is positive. That means the body is increasing its velocity. The velocity is increasing. What if I have negative acceleration? Okay, in this period I will take these 2 points, acceleration from 10 to 12, for example 12 and a half. The third period is equal to v2. I will take this, and v2 is equal to 1. I'll use this color, minus v1, which is 3, divided by the difference in time, which is 12 minus 11, which is equal to 1. 1 minus 3 is minus 2 over 1, which is minus 2 meters per squared second. This means that the body is deceleration. Decelerate, okay. The acceleration is in negative sign. That means the velocity of the body is reduced. The acceleration here, we can compute the slope. We can find it is 0. So the acceleration is 0. Okay. Now we need to use the same graph to find the acceleration, average acceleration between different points, and the instantaneous acceleration, we will find it in another graph. So find the acceleration during these points. You can do that. What is the unit of the acceleration? We found it, which is meter per square second. Be careful for that. If the acceleration is positive or negative, what is the mean of that? If it is positive, then the velocity is increasing. If it is negative, the velocity is decreasing. Here is acceleration, we can call it. Here also we can call it deceleration. But in both cases, it is acceleration, positive or negative. I think you can do that by yourself. It is easy. See you in the next example. Hi students. Now I will talk about a graphical interpretation of acceleration. You can find that in page 29 through 30. As we talk about the graphical interpretation of position and velocity, now we can find the acceleration from the graphs in between velocity and time. We see the previous example, and we will for straight lines we will use now curves. It will be easy. We will draw also tangential lines to find the instantaneous acceleration. Okay. Let us now find the average acceleration between the points t equal to 0. This is equal to t equal to 0. And t equal 0.6. This is 0.5, 0.6, 7, 8, 9, 1. This is 0.6. So I need this point and this point. I need the average acceleration between the point A and B and C. I have to find where's the this point, what is the coordinates of this point. Okay, also between t equal 1, this is t equal 1, and t equal 2.2, this is 2.1, 2.2, this is time 2.2, and this is the point where's 2.2, and the velocity, it is about minus 22 meters per second. I have the velocity here. Okay. I think it will be easy to you. I will compute the first one. I can compute it by just without drawing any lines. I'll draw the line, but I can compute the acceleration, average acceleration. I can put it A average is equal between, for the first point, between the point t equal 0 and t equal 0.6, which is equal to v final minus v initial over t final minus t initial. This will give me the acceleration. The average acceleration is equal to v final. If I have this 0 and this 10, so I have it, this one is 2, 3, 4, sorry, this is 6, this is 8. So the final velocity is 2 minus the initial velocity is 0. The time is here, the time is 0.6. I can put the time 0.6 and the velocity, which is 2.0. So the difference in time is 0.6 minus 0, which is equal to 2 over 0.6. And the acceleration is equal to 3.3 meters per squared second. I can put the units here also, but I don't need to confuse myself. I can keep them to the last, but I have to put them. I am a physicist. You are a physicist now. You are not a mathematician. If you are a mathematician, you need to put just the numbers. But in physics, we have units to know that and to know more about these quantities. Now the acceleration is a vector, so I need to use the vector sign over the acceleration. What is the direction of this vector? I told you before, the positive direction is with the x direction, the positive x axis. So in this case, I have positive direction, and this direction is the negative direction. Okay, so the acceleration in the positive x direction, or to the right, or to the east. Okay, I can also compute the acceleration between A and B. So the acceleration, average acceleration between A and B is equal to V at B minus V at A, which is the difference in velocities, the over the change in time. This is the T final, or TB, and this is TA. TB is 1.5, 1.6, 1.7. I will put it TB minus TA. I will put the numerical values. VB, it is this is 0, 2, 4, 6, 8. It is 6 minus VA, which is the same value, 6, divided by time at B is, as we say, 1.7, minus the time at A is, this is 0 0.5, 0.6, 0.7, 0.8, 0.9, 0.9. This is equal to 0 over 0.8 meters per squared second. We have no any accelerations, average acceleration between A and B, but that means if I draw a line, this line will be horizontal. The slope of the horizontal line is 0. The average acceleration for this line, or for this graph between these 2 points, is 0. But what if I take the instantaneous acceleration at point B? Okay, what I need to do is just to draw my tangential line like this. And I need to pick 2 points and compute the acceleration again. And I will do that now. You can do that by yourself. You are better than me, I think. This is my line. Your line will change a little bit. Okay, this is the error of our experiment. Each experiment has an error. This is experiment. I will pick this point, which is easy to be found. Where is the coordinate for this point? I will call it beta. By the way, we will deal with different samples in Greek letters. Okay, I will pick another point good to me, which is approximately this one, or maybe your line will be better than mine. I can take this point or this one. I'll call it alpha. At alpha I have t versus velocity at alpha, and at beta also I have t versus velocity at beta. What is the time at alpha? It is 2 seconds. What is the velocity at alpha? It is this is 2 in minus sign, 4, 6, 8. It is approximately 9 in minus sign, negative sign. So my velocity here, it is 9, and the units in seconds, meters per seconds. Okay, what about this point? The time here is 2.1, 2.2. The scale for x-axis or the time axis and the y-axis, which is velocity, it is different. You need to be aware about that, because look, from here to here is 10 units in velocity. From here to here is 1 unit in time. Okay, so the time at beta is 2.2. And the velocity at beta is negative 18. You can find that. Okay, now the instantaneous, or the slope for this line, which is the instantaneous acceleration at B, point B, is equal to the slope of this line, which is equal to the difference in velocities, or divided by the difference on the times. Okay, the velocity, this is V beta minus V alpha over T beta minus T alpha. Again and again, I can compute that, which is equal to V at beta is minus or negative 18 minus V at alpha is negative 9. T at beta is 2.2 minus 2.0, which is equal to negative. This negative with this negative will be positive. I have negative 18, positive 9. The result is negative 9 divided by 0.2, which is equal to how much? Negative 45 meters per squared second. Look, The negative sign means that the velocity at this point is decreasing, yes. Okay, what if I take the acceleration at this point? I don't know what the name of this point. The slope is negative also, but the slope is less in magnitude, less than the slope at B. That means the velocity or the body at this point increasing its velocity, but not in the same rate as in this point in this period. We have change in velocity in 2 points, but this change is depend on the slope of the tangential line. Maybe if this one is negative 45, maybe this one is negative 30. If we have at the point A, this is the tangential line. At A, we have another tangential line at another point. Maybe this one. Look here. Sorry. Or this point here. The tangential line here is horizontal. Slope is 0. The acceleration is 0 meters per squared second. I think you can repeat this solution many times and calculate the instantaneous acceleration as you done before for the velocity, and you can find the slope of any line. See you in the next examples. Thank you.